Adding and subtracting complex numbers couldn't be easier. All you do is add or subtract the real and imaginary parts separately. Just being careful of negatives, as if I'm subtracting a negative, things like that. But apart from that, it's quite straightforward. So here are the two numbers in rectangular form. 5 plus 3j plus 6 minus 2j. Add and subtract the real and imaginary parts separately. What that means is I add the real parts. 5 plus 6 is 11. And I add the imaginary parts. 3j plus minus is minus 2j. So 3j minus 2j is 1j. And we, similar to x and algebra, we don't bother to put 1x. Equally, we don't bother to put 1j. J means one lot of j. So 11 plus j. Watching the double negative, add the real parts. 3 minus 4 is minus 1. 2j minus minus is plus 6j. So we would end up with minus 1 plus 8j. So that's straightforward. The only thing is, what happens if it's in polar form? Because often, as I was saying earlier, we're interested in the size of the vector and the angle. So the polar form is often how we want to leave our answer. But we cannot add and subtract in polar form. So if I want to add two numbers in polar form, I convert to rectangular and then add them and then convert back to polar again. I cannot add and subtract in polar form. You might have spent some time adding forces. So if I have one force vector and another force vector, it's like the top to tail method that you might have done in mechanics. Well, if you think about it, what you're actually doing is saying, well, what's the x component of this force? And what's the x component of this force? Add them together. What's the y component of this force? What's the y component of that force? Add them together, and then you get the resultant. And that, if you think about it, is exactly what you're doing here. If I want to convert two numbers in polar form, the first thing I do is rewrite them in rectangular form, and then I can add them. Add the x and y components separately, in other words, or the real and imaginary parts separately, and then finally convert back. So just as a quick calculator exercise effectively, what you've got to do to add these is convert each one to rectangular form, then add them, and then convert the answer back to polar. So I'll just pause while you do that. If we do this, 1 or 2 points to make as we go along. The first one, 8 angle 45, turns out to be that, look. Is that a coincidence those two numbers are the same? Why isn't it a coincidence? Why must they be the same? Because it's 45 degrees. If you think about 45 degrees of the rectangle, the triangle, remember, 45 degrees, x and y must be the same length. So that's not surprising. This one, 13 degrees, I'd expect x to be almost 7, which it is, and y to be not far up the y-axis, the imaginary axis. So convert them both. When you do this, of course, you're rounding. I mean, I rounded both of those numbers, so that one of the problems with this method is, when you're adding numbers in polar form, is your answer is going to be a rounded answer. It's not going to be exact. But there you go. So now we add the real parts and the imaginary parts together, and then finally convert that back to polar form. And so we get a vector of length 14.42 at an angle of 30 degrees to the positive real axis. And that would be those two vectors added together. Those two complex numbers added together, using complex numbers to represent these vectors. So that's adding and subtracting complex numbers.